In the broad and dark night sky, among the bright spots that guided our ancestors and inspired our imaginations, lies a star that has long fascinated and troubled the mind of astronomers. Located in the Orion constellation, this star is no ordinary celestial body. A giant red giant known as Betelgeuse, often spelled Betelgeuse. For centuries, this great star has been the subject of wonder and fascination. But recently, Betelgeuse has started to behave in ways that are not only suspicious, but terrifying. What if the strange appearance we see is not, as many scientists believe, the singing of a star, but a sign of something much more sinister? Think of the starry sky as a stage for a planetarium show. One of the brightest artifacts, Betelgeuse, has begun to shake and shake, giving rise to the suspicion that the end of the game is near. But since it's a veil of inconsequential elements, maybe Betelgeuse isn't ready to go out in a blaze of glory? But what if it is about to plunge into the depths of the universe, threatening not only its celestial neighbors but the very fabric of the galaxy itself? Join us as we dive into new research and explore Betelgeuse's surprising future, a future that will change the world as we know it. Betelgeuse is a star that defies simple description. About 950 times more massive than our Sun, it is one of the most massive stars in the universe. However, size comes at a price. Massive stars like Betelgeuse burn through their core fuel at such a rapid rate that their lifespans are relatively short compared to smaller stars like our Sun. Betelgeuse is a ticking time bomb whose fiery intensity is accelerating as it nears a cataclysmic supernova explosion. Although this event is very real, the exact time is one of the great mysteries of the planet. Located about 650 light-years from Earth, Betelgeuse shines as the closest star to Earth, making it a major target for astronomical research. The glow is undeniable, although only 13.3% of the energy we can see. If we can see Betelgeuse in its full glory, it will outshine Sirius, the brightest star in the night sky. But the story of Betelgeuse is not just about its brightness. It's about what lies beneath, in the core of this magnificent star, where nuclear fusion has fueled life for millions of years. Imagine a supermassive star whose radius extends into the asteroid belt and would nearly touch Jupiter if it were in our solar system. In this great world, the Earth, Mars, Mercury, and Venus are engulfed by the force of gravity. But the surprises don't end there. Every 1,000 years or so, Betelgeuse sheds a solar mass and sheds its outer layers in a dazzling display of cosmic magnificence. This process creates a huge cloud of gas and dust many times larger than the star itself that surrounds Betelgeuse, swirling it into an ethereal haze. This cloud spans over 30 light-years and invites us to discover the secrets of this great dance. At Betelgeuse's heart, the nuclear fusion of hydrogen and helium has fueled the star for most of its life. But as the hydrogen fuel becomes less and less, the star undergoes a divine cycle. When helium is absorbed into carbon, it releases energy that flows throughout the universe. But even this brilliant combination has its limits. As Betelgeuse continued to grow, heavier elements such as neon and iron began to form, bringing about the death of the star. The life of a star is full of changes. Once a young and energetic blue star, Betelgeuse has become a fiery red star. Historical records from the 2nd century BC describe Betelgeuse's characteristic yellow color, distinguishing it from celestial bodies. Over the centuries, astronomers from various cultures, including the Greeks and Romans, have observed and recorded the color and brightness. These observations, passed down through the generations, add to the intrigue surrounding this mysterious star. In recent years, the story of Betelgeuse has changed. In 2019, the star surprised scientists with its sudden dimming. At first, scientists thought it was a huge dust storm coming from the surface of the star that was blocking our view. However, the origin of this cloud is not clear. Others believe that a large body, perhaps a rogue planet, disrupted the star's surface or was swallowed by it. But in recent months, Betelgeuse has defied expectations, nearly doubling its previous brightness. A remarkable development for a star nearing the end of its life. To fully understand the fate of Betelgeuse, we must delve deep into the core of the dead giant. Here, nuclear fusion continues to increase the brightness and size of the star. First, hydrogen is absorbed into helium, releasing a large amount of energy. As hydrogen decreases, the core contracts under pressure, increasing temperature and pressure. This causes the helium to mix with heavier elements like carbon and oxygen, and the star becomes supermassive die-in stars the size of Betelgeuse. This process is very difficult. The core is composed of several layers, forming a solid shell in which the various elements melt. Each step changes the structure of the core and the output of energy, resulting in dynamic and unstable behavior of the star. When Betelgeuse runs out of nuclear fuel, it won't have enough energy to resist the force of its mass. This leads to a massive collapse of the core that results in a supernova explosion. The supernova process is one of the most fascinating and dangerous phenomena in the universe. As Betelgeuse's core collapses under its own gravity, it compresses at great speed, forming a neutron star or black hole. This collapse creates a massive shock wave that travels outward through the star's outer layers, heating the surrounding material and exploding in a light and powerful explosion. Betelgeuse's outer layers are ejected into space, enriching the surrounding interstellar medium with heavier elements, materials that help form new stars and planetary systems and continue the cycle of galaxy evolution. The explosion of a giant like Betelgeuse has far-reaching effects on its surroundings. The material produced by a supernova influences the formation of new stars and planetary systems. Shock waves from the explosion collapse nearby molecular clouds, giving rise to new stars and new planetary systems. In addition, the heavy material created in Betelgeuse's core that is ejected during a supernova contributes to the chemical enrichment of the galaxy. These elements are important for the formation of planets and the development of life, so the life cycle of Betelgeuse is a major force in shaping the chemical composition and structure of our galaxy. Throughout history, Betelgeuse has been a famous feature in the night sky, influencing many cultures and astronomical studies. The ancients often observed and recorded the phenomena of celestial bodies, and Betelgeuse with its unique color and brightness was no different. In medieval Europe, Betelgeuse was associated with various myths and astrology. Its red color and its prominence in the Orion constellation make it a wonderful reference point in the night sky. The appearance and variation of brightness was considered a sign in different cultures. In recent years, Betelgeuse has attracted the attention of modern astronomers due to its unusual appearance and potential for a supernova event. Advances in observing technology, including space-based telescopes and advanced imaging techniques, have allowed scientists to study Betelgeuse in unprecedented detail. Scientists use a variety of techniques to monitor Betelgeuse's behavior, including quantitative imaging to measure changes in brightness and spectra to analyze the star's structure. These observations help scientists understand the current state of the star and predict its future evolution. Predicting the exact timing of a supernova event is a complex and difficult task. Although scientists can estimate the probability of a supernova based on the age and behavior of the star, accurate predictions are difficult because of the many variables involved. Factors such as the star's mass, composition, and environment affect the timing and nature of the explosion. Current models of stellar evolution and supernova mechanics provide important insights, but there is still much to learn about the unique phenomena that occur in supernovae. Continued observations of Betelgeuse and other large stars are essential to refine these models and improve our understanding of these amazing planetary events. Betelgeuse is an important case study in stellar evolution. By studying the behavior and properties of stars, scientists can understand the life cycles of other massive stars and the processes that cause supernovae. Betelgeuse's unique properties, such as its size, brightness, and erratic behavior, make it a good candidate for studying the later stages of stellar evolution. Observations of Betelgeuse will contribute to our broader understanding of the dynamics of massive stars, including what affects their lives and the processes by which they collapse and explode. Betelgeuse's future is one of the planet's most pressing questions. Will the star continue to shine and signal an impending supernova, or will it take hold and delay its final end for thousands of years? As Betelgeuse continues to defy expectations, astronomers around the world eagerly await the next chapter in the history of this mysterious star. Whether Betelgeuse explodes tomorrow or in a million years, its legacy will remain as a symbol of cosmic wonder and a symbol of the dynamic forces that shape our universe.